Yeah, look at now. Your figure shows a mixture of blue, green, red colors incident on a on a right angle prism. The critical angle of the material of the prism for the red, green, blue is given as 46, 44, 43. The arrangement will separate. What will happen? They ask him to find. So first of all, now we know the visible light, that is VIB GYOR. It's a visible light now. As we move towards a red, what happened to wavelength? If we move towards a red, what happened to wavelength? Increases. If we move towards a red, wavelength of the light increases. Okay. Now, which has a high wavelength, you can see now? Which has high wavelength? Red has high wavelength compared to blue and green. Okay, this is the first thing. Right. Now, if the wavelength increases, refractive index also increases, keep in mind. So here, this one, wavelength for the red is greater than wavelength of blue. This is order, we can wavelength of green, and thereafter wavelength of blue. This is the order, right? Now, as a wavelength increases, refractive index also increases. Wavelength is directly proportional to refractive index. Red wavelength is more, refractive index for the red is greater than refractive index of a green, and thereafter refractive index of a blue. This step clear now, first of all? Yeah. Now, so that's why. Now that's the reason. So here they given the critical angles given. Critical angles for red is given as 46, green 44, and blue given as 43. Now, so here all these light rays which are coming like this, the light ray which is coming like this. So at the surface, the light ray is coming normally, then that's why the light ray doesn't have any refraction. Where the light ray will incident at this location now, and we'll see this thing, what's going to happen here. So at this location, now if I call this is a normal here, this is a normal. Look at now angles here. So this angle is given as 45 degrees. That means this angle is also 45 degrees. Okay. Now, so this angle, this is the 90 degrees, means this angle is 45 degrees. Yes or no, tell me. This is 45 degrees. Okay. That means angle of incidence is how much, you tell me? 45 degrees. This point clear now, first of all? Angle of incidence, which is equal to 45 degrees. So here now you tell me now, this light, the light is inside, light will contain all these three colors. Okay, but the angle of incidence for each color is same only, 45 degrees only. Now look at now, angle of incidence. Now we'll talk about this is a red color. If we talk now here. So what is the critical angle for the red color? You tell me now. Critical angle for red is how much? How much the critical angle for red color? 46 degrees na? Critical angle for the red color is 46 degrees. Now you tell me now here, So the angle of incidence for red color also 45 only, blue also 45 only, green also 45 only, isn't it? That means in this case, you tell me now, is the angle when we have a TIR will happens, you tell me? When the TIR will happens? If the angle of incidence is greater than the critical angle, then only TIR is possible. Here, how much the angle of incidence now here in this case? Angle of incidence is 45, critical angle is 46. Do you have a TIR will happen or refraction will take place? What will happens now? TIR is refraction. So here the angle of incidence is less than critical angle na, isn't it? So that's why what happens now? Refraction takes place. So refraction means what element? Red will come outside. So red color will come outside. Okay. Next, now you tell me now here. And the next one. Yes, critical angle. Critical angle for the green. How much? Critical angle for the green is how much? Yes, green is 44 degrees is given. Now you tell me now angle of incidence same only na angle of incidence. Now you tell me here this I greater than the critical angle, isn't it in this case? So what happens now in this case? TIR will happen or not? Yes, so that means green color. So green color it will move like this only na? Yes. Green color will experience it. Yeah. Next one, blue color. What happened to blue color? Here, what the critical angle? Yes, critical angle of blue, which will be a 43 degrees. Now tell me what happens now here. Angle of incidence greater than the critical angle. So what happens now here? TIR or refraction takes place? TIR. So that means blue also will come this side only now. Right, from this what we can comment now here, red is separated from green and blue. Red is separated from green and blue, isn't it?